Okay, let's get started. Well, good morning, everyone. Morning. Well, welcome to today's session on developing microservices on Kubernetes. And the key words for this session really is on iterative development. So my name is John Stallo. I'm a program manager on the Azure Developer Experience team. And I'll be joined on stage a little bit later by Lisa Guthrie. And together, throughout the session, we're going to cover three broad topics. The first one is we'll cover some of the challenges in developing microservices. The second, we'll be sharing some of the solutions that we've been developing to address some of these challenges. And third, I'd really like to be able to help you learn how you can actually engage and participate. A lot of what I'm showing today will be is in private preview. We're expanding that program. And it really is a great time for you to be able to jump in, engage, participate, help shape what we're building, some of the services that you'll see today. First off, who can tell me what this is? Punch cards, programming punch cards. I'm curious. Anyone here in the room actually programmed with punch cards? Oh my goodness, that's awesome. Programming punch cards was a little bit before my time, but I remember I had a lecturer at college many years ago who kept on reminding us as students how good we had it. Because she would describe this development process that was like totally foreign to us. She described developing out her algorithms literally on pencil and paper, and then at some point it got converted to these punch cards. This is a line of Fortran code here, and so you would have the stack, and then you would actually schedule some development time in the lab where these punch cards would be loaded, and God forbid you actually dropped your cards, because that would be like a total mess. And so then your program would run at its allotted time, and there would be a printout of the result. And she would say more often than not, you would have the result of something failed at this line, and you're like, okay, well, I'm back to the drawing board. And that feedback loop for us as students just seemed like totally crazy, right? Because back then we were programming on C. And so we had our editor and our compiler on the same machine, and you just edited your code, ran, tested it, edited, compiled, run as often as you wanted, until you got it kind of right, enough to be able to submit for assignment marking, and you knew that whoever was evaluating the assignment was actually going to be running your app pretty much on the same machine or type of machine as what you developed it on, right? And so I guess we had it good compared to programming with punch cards. But I wonder, as more apps become, as we begin to develop more cloud-native apps, whether that gap is actually just starting to grow out again, right? Because you develop your code over here, and there's all this, a lot of setup and so forth to get your development environment just right. And you're writing your code, and you're iterating, and you're shaping it, you're experimenting, and so forth. And at some point, you check it in, and it's over here that it actually gets integrated with other code you've never seen before, right? And that's actually now running in an environment that you actually didn't develop on. And that gap is wide, and it's growing even wider as cloud services dependencies are actually growing in apps today. And so that iterative loop is actually now starting to expand again, and you're getting a lot of latency back into your development experience. I'm wondering, has anyone built mobile apps? Okay, so many of you. I think you would agree that despite the best emulators, simulators, and so forth, there's never quite there's nothing like actually just being able to hold your device in your hand and test your app that you built on your device, right? Like there's that, simulators can get you so far, but then at the end of the day, you really want to be able to run your app and see your app where it's actually being built for. So we think that we could provide a better cloud-native development experience. And so I'd like to maybe introduce that by way of demoing, just kind of getting started. You probably saw at the keynote on Mondays, Scott Hanselman showed dev spaces with AKS. And so that's what I'm going to start showing, but perhaps just as a, how do I get started experience. So I'm going to flip over here to my demo machine. And so literally all that I've needed to do is actually install the Azure CLI, a special version of it because we're still in private preview. But I have the Azure CLI, and that's actually all I need. It's a very lightweight setup experience. Anyone here actually created AKS clusters? Okay, so a good portion of you. So let me just go over maybe some basics. You can do that right from the CLI. Can everyone see that? Should I bump it up a little bit more? Is that better? Yeah? Okay. So you can jump right into the Azure CLI. You can create a cluster here. You can provide all sorts of settings, but you can just go with defaults. And you would give the name of your cluster, the resource group, and so forth. You can also, one thing I want to call out is just going over to the portal. If anyone's been playing with AKS this week, you'll notice that there's been really a lot of improvements in actually creating your cluster in Azure. So you would go to here, create a resource, under containers, Kubernetes service. And this has gotten a lot better. You don't need to create an SSH key and upload that, and service principals and all of that. That was kind of some early iterations, but here the experience is a lot more streamlined. One of the things I would call out, which we'll be using today, is if you go over to networking and you can see there's HTTP application routing, and you can just turn that on, and that now is built in to AKS. So that enables integration with Azure DNS. And now you can actually have containers running inside your cluster that have a public ingress just built in right into AKS. So that's a big improvement there. Okay, so back to being able to develop with AKS. So assuming that I've got a cluster already, my next step is to develop against it. And one of the things that you enable is what we call Azure Dev Spaces. It's just another service. It's kind of a companion service that helps you develop and give you a great iterative development experience with AKS. And so the way that you use Dev Spaces is quite literally, you say AZ AKS use Dev Spaces. And then your name of your cluster, which I'm blanking out right now. Let's see, so AKS list. I've got quite a few. All right, so let's just grab this one here. So the resource group of my cluster, the name of it, and that's it. So now what I'm doing is I've enabled to be able to use dev spaces with that cluster. My next step is to just run some containers in that cluster. I'm currently, my current directory, I'm in a code folder that has Node.js code. Later on we'll see that this works with .NET and other languages and so forth. So, but for now, I've got like the most simplest Node.js file, but nothing else really. I don't have any Docker files in my code folder or anything like that that would help me actually package this and actually deploy this to Kubernetes. So one of the things that I can do is I can say AZDS, and I'm saying, well, where did that come from? Well, that would have been downloaded for you and installed right at when you use that use dev spaces command. Going forward, our plan is to bring that into the Azure CLI. But for now, this is where it is. So I can say prep, and that will actually go out and look at my current code folder, and it will generate a Docker file and a Helm chart for me. The other thing that I can also pass in is this particular Node.js app is kind of like it's an Angular app, and it calls back into the back end. And so I would like to make this a public service. So you can see what it did is it gave me a Docker file, it gave me a Helm chart, and kind of the important tenet for us here is that right from the beginning, you're using the same assets during development as you're testing. Later on, you're using the same assets in the way that you build your container, the way you deploy your container, for later on in production. So these assets should serve you well throughout all of those stages. And so now that I've got the Docker file and Helm chart, I can just say up. And with networking and portal and everything that I depend on for this demo, hopefully we'll see this start up soon. Ish. All right, just needed a little bit of prodding. Okay, so what this is now doing is taking whatever I had on my local machine, the code that I've got in this folder. Remember, none of this is really checked in. I don't need a repo or anything like that. So it's got that here. Now it synchronizes that up into AKS, where it actually starts using the Helm chart that I described in my code folder to actually deploy my app. You can see that I actually started to build my container image. And then, because I specified -- public, and so now it's given me an actually public URL to test this on. So I can just open that up and hopefully that will kick in. You can see the actual container is actually running because I've got like listening on port 80. That's part of my Node.js app. Sometimes DNS caching is a problem. Let's use this URL and see. Okay. So can you see at the top there where it says localhost? Really, that isn't actually my app running locally. It's actually just opened up a SSH tunnel to the AKS cluster. And so that's another way for me to be able to connect there. Let me just check one thing. Let me see if can my phone connect to it? My phone can connect to it. All right. So through the public endpoint here, let me just see. No, I'm having some issues here. So bear with me. I want you to see actually what's on my phone instead. So not my ugly mug. Okay. You can see up here, web front end, that was the name of my folder, so it just gave me a default name for my Helm chart, which actually ended up being my service. Web front end, I'll read along GUID, followed by .aksapp.io. And so now I've actually got a public endpoint where I can hit my web app. And as you can see, it's functional. I'm hitting a button and it says hello from, it's making a call back to the back end. But it doesn't look that great on my phone. I mean, it's all zoomed out. I think I've got like the viewport all messed up. But hopefully there you just saw that how easy it is just to be able to get some code wrapped up in a container and a Helm chart. If I had it there, I would have used it. But if I didn't, it would generate one for me. And then I just say up, and it goes and builds a container up in the cloud, runs it in Kubernetes, in AKS, and it's now available as a public endpoint. That's all very good, but we're talking about iterative development. And as you can see, my app doesn't look great on my phone currently. So let's move out of here. And let me open up VS Code. And immediately, one of the things that I'm prompted for is it detects that actually, this is I've got a Helm chart and a Docker file here, and there's an extension here that I installed, DevSpaces extension for VS Code, and it's actually prompting me to whether I want to generate any debug configuration for this to help me actually get a debug experience with this. So I'll say yes for that, and I'll go over to the debugger, and it says it's set up some profiles for me. And let me just run that. And now this is going to rebuild my, my container and redeploy it, because I've actually asked it to do that with a debugging port set up. So it's just going to go through that again. Okay. Can everyone see my code? I need to bump it up a bit. Maybe too much. Okay. I have a bug here. I haven't set the viewport correctly. Wouldn't it be great if all bug fixes were actually fixed by just uncommenting code? But that really helps me. What did I do? I just I modified some HTML, I saved it, and then on my phone here, I'm just going to refresh, and you can say, now I'm able to validate that my bug has been fixed. If I go over here, let's just make some other changes. Let's say another HTML change. Over here, let's just change the color. I'm going to save. Just refreshing my app over here. It's giving me a connected experience, right? Like I can actually see these code edits take place not on my local machine, but in the cloud where this app is supposed to run in the end. So that's HTML, and that's what is happening is it's just syncing that file into the running container. If I go in and modify, say, some server code, so I'm just modifying where it says, hello from front end. Save that. Any luck? You can see that just takes place immediately right there. Again, that connected experience, something that I think is missing from today's cloud native development, is what we're striving for. Now remember, all of this is pre-commit. This is at the stage where I'm still experimenting, I'm modifying, I'm shaping my code. I want to see the results very quickly, but I want to see it in an environment that is more than just my laptop. I want to see it actually running in the cloud. Is there anything else that I wanted to show here? Oh, well, breakpoints. Obviously, that's going to, here we go. All right. Press the button, hit breakpoints here. I can, I've got access to all of the rich information inside VS Code or Visual Studio. You can see, stepping into over code and so forth. It's very responsive, but I'm just connected directly into that container running in AKS. If I jump out into one of the nice things is when I've connected now to that cluster and I've got that session going, kube control is already connected as well. If I had that installed, so I think I can just say something like get pods, and you can actually see out of all the stuff that's running in the kube system namespace, there's also one that is in my own namespace, web front. So that's in Kubernetes there. Is that cool? Yeah. I have a question here.
Is it possible to do that on a non-public endpoint?
Is it possible to do this on a non-public endpoint? The answer is yes. And that actually brings up an important point. So if I would have just done a prep without the public, containers are secure by default. And that would mean that container runs in my cluster, in AKS, but there's no way to be able to get to it. And that's actually the default. And so what you saw me kind of troubleshooting is while you're running that F5 debug session, we open up an SSH port. So just to make it easy to be able to curl against it, ping it, whatever, test it directly. But then that tunnel closes when you close your debug session. So by default, things are secure, and we offer an experience to be able to develop those kinds of containers, which would actually be most of your services running in your cluster. Good question. I have another question at the back. Can you put your own cluster in your own subnet? That, I guess, is the more general question of custom VNet support. That's a very common requirement that comes up in a lot of organizations. The answer is we're getting there. AKS, I think, already has custom VNet support that they're previewing, and we're working to get this experience working in that kind of setup as well. That's a very high up in priority for us, absolutely. Okay, let me move on, but I would definitely, if there's questions coming up, we'll make this interactive as we go along. Let me just skip over now to slides. So I said this before, I just want to iterate it. This isn't about like writing code and directly into production, right? This is really about me being able to experiment, shape my code all before I'm ready to commit. And so giving you that iterative, fast development experience directly in Azure. And then we saw like there's the different kind of levels of things that happen when you're changing files and then doing an up or an F5. And so we found that really the only way that we were able to really provide an experience that you're used to of like when you're running things locally and you're expecting that really fast iterative experience is to not always have to rebuild the image and deploy it to a container registry or push it to a container registry, deploy it, and so forth, as if you're doing a full CI/CD pipeline. It doesn't make sense when you're just modifying some code and wanting to see it immediately before you check in. And so if you're editing any content, like HTML, CSS, and so forth, as soon as you make that save, we're just synchronizing it directly into the running container. If you're modifying some server code, what you saw me there is modifying some Node.js server code, and what happened there is we saved the file into the running container and just restarted the node process. And this is pretty much what happens when you're running NodeMon, let's say locally. We're providing the same experience for you in the cloud. But there are other changes that you do which are more impactful. Like I modify my Docker file. That's actually changing the definition of my container. If I modify my Helm chart, or I'm adding dependencies in package.json or NuGet, whatever, those changes will automatically detect and say, all right, you've just made a change. It will blow away the container image that's there, rebuild it, and redeploy it. So we're fine-tuning this to be able to provide a good iterative experience, and you're able to also go in there and have control over that as well. So if you always want to just rebuild and redeploy from scratch every single time, you can do that as well. You have that control. The idea then is once you're happy with your changes, then you could commit. Then your CI/CD pipeline takes care of actually really building your image and deploying to pre-prod environments. So what we saw was some very lightweight local machines setup. Kind of take out all the hassle of you need this and that, and you need a Kubernetes cluster, you need to install Helm on it and Docker and all that, and just to be able to kind of get started, all you need to do is just install the CLI. Use the same Docker and Helm assets from development through to production. Run any language and any framework. Run on Windows, Mac, or Linux. I was showing that on Mac, and we'll see what a Visual Studio experience looks like. next. And at this point, I'd like to invite Lisa Guthrie, who will show us, if you're a Visual Studio IDE user, hands up, folks who, all right. So this part is especially for you. You'll see that there's some extra goodies in there for doing Kubernetes development inside Visual Studio. And you are number 8. Let's do this.
All right. Yeah, so what I'm going to walk through real quick is what the Visual Studio experience looks like for what John just went through. So here I have an ASP.NET Core web application, just the default template in Visual Studio. And you can see up here, just as it's been for eons, my default debug experience is to run this locally in IIS Express. But because I have the Azure Dev Spaces extension for Visual Studio installed here, I have a new option in this drop-down menu. And the option is Azure Dev Spaces. This is going to go out. It's got my list of AKS clusters here. So I'm going to choose here, if I've got a cluster that is not yet set up for Dev Spaces, when I click OK here, Visual Studio is going to prompt me to configure dev spaces on this cluster. This, if I click OK here, this is equivalent to that AZ AKS use dev spaces command that you just saw John run from the command line. But I do have a cluster that's all set up with Azure Dev Spaces already. Oh, sorry, I should have mentioned there, you also saw that publicly accessible check mark, which is equivalent to the -- public command line switch that John passed in at the command line. So in Visual Studio as well, you have the option to publicly expose this particular service on the internet. You can also, to the question that was asked, that is not on by default. So normally, oh, where'd Visual Studio go?
You know this is live when you see that. So.
Of course. Yeah, so as John mentioned, that checkbox is not on by default. And so if you don't check that, then you don't have that public endpoint. All right. Yes, it came back. This is actually Visual Studio 15.8 Preview 1. So it's the preview that we just made available this week. So yes, you can see that things are a little bit, they can be a little bit unstable, but we're working on cleaning that up. But it did reload here, and it reloaded my project again. And I just want to point out that we have all the same artifacts that you saw John show at the command line. So when I go through this experience, it's essentially equivalent to doing the AZDS prep command here. I've got my Docker file here. I've got the azds.yaml file, which has a number of settings that are related to AZDS. And I've also got my charts here, my Helm charts in the charts folder. So that is the equivalent Visual Studio experience to what John was showing at the CLI and in Visual Studio Code. And then, of course, now my debug launch target is set to Azure Dev Spaces. If I click this, that's equivalent to debugging in VS Code, like John was just showing. And we'll see that experience here in a little bit. We'll walk through more of a demo. But those are the basics of getting started in Visual Studio. We're bringing a lot more into Visual Studio to make Kubernetes development easier. We have a new template, or we've got some new tooling around Kubernetes that adds a Kubernetes template in your new new project dialog. We're also working on a publish experience, so publishing directly from Visual Studio into Kubernetes. If you don't want to do the CI/CD pipeline when you've iterated on your code and you're not quite ready to set that up, we'll have a really easy experience for getting your code up and running in an AKS cluster as well. So that's what we've got in Visual Studio for Kubernetes developers.
OK, thank you, Lisa. And later on, Lisa will be, we'll show a little bit more of Visual Studio and developing microservices there. Everything that I've shown so far, that Lisa has shown, has really been just a kind of just a basic get your first container running in AKS. And hopefully you've seen that that is very simple, but that's not microservices, right? Like that's just a single container now running in my cluster. Some of you may have seen, again, the demo around the Smart Hotels 360 app. What I've just pushed out over here on the slide is really some of the architecture that's behind there. It's a web app, but it's really broken out into many microservices. They're all independently running. There's a lot of dependencies, cloud dependencies that this app depends on, both internal, such as Cosmos DB and SQL and Postgres, as well as external data sources like Twitter and so forth. And all of that there's a lot of moving parts to it. I guess one of the questions that maybe we should just pause a little bit is like, why on earth build out a microservices architecture? This isn't the talk to really go deep into that. And in fact, there's a lot of folks who actually highly recommend that you don't start off building microservices, right? Like you start with a monolith first. And in that way, you get a sense of what really needs to be broken out. What are the domains in your app? But the truth is that you do get to a certain point where a microservices architecture actually starts to make sense. When it starts to it makes sense to actually pull some things out into smaller, independent microservices. Some of the many common reasons that I come across in speaking with folks is just being able to get teams to independently develop different parts of the app in parallel, but without like clobbering over each other in terms of like when they're releasing or when they're what kind of dependencies that they're taking on. Can they upgrade to a specific framework version or bring in a library? How will that affect everyone's code? That becomes really, really nasty. And so the ability to have different teams develop in parallel, being more in control about their dependencies and when they actually update is but one of the many advantages of microservices. But the truth is, once you start getting into that world, there's now a lot of moving parts. And maybe just to walk through a scenario of what does a developer experience look like, particularly as someone who's actually new to the team, is actually onboarding. What does that look like often? One of the conclusions is, well, they're really hard to develop locally. Let's see some of the reasons why. So let's say that I've got this app with all of its moving parts. It's all running, let's say, in our what we'd call maybe a traditional integration environment. Maybe this is a cluster here. I've got some services running inside, front end calls hotels, calls promotions, a whole bunch of other stuff that's around it. I've got data sources as well. And let's say it's my job. I own the hotel's service. So I'm going to make some modifications to the hotel service. So I've got to go and set up my local machine, whatever tools that I need, frameworks to get installed on that. But then, in thinking about my application, well, before I can work on hotels, well, hotels depends on a service called promotions. And promotions has its own data store. And so I need to know how to figure out how to build and run promotions and its data store. And then finally, I can actually start getting hotels running, which is okay, and I do that. Modify some code, get that running locally, and at some point, I'm like, okay, I've done some local testing here, unit tests and so forth, I'm ready to commit this. So you commit that, and if I have a CI/CD pipeline, it will pick up those changes and actually deploy my modified hotels. And that is the environment in which probably is the first time that hotels is actually running where there's other stuff that I haven't run locally. There's probably even changes to promotions, other dependencies that I didn't sync to on my local machine, but now is over there. And that's where we start seeing some of the end-to-end integration issues that start to happen. And then you move on with, if things look okay in that integration environment, then you start moving to other pre-prod environments and finally to production. Okay, so what I've described there are some kind of standard flows that your code would go through. But it has some key assumptions here. One is that I know the full dependency graph of my service. And that starts to become a lot more challenging in a microservices world. You don't actually always know who calls you and what that full request line is into your service, as well as what your full dependencies are. Like maybe I call directly promotions, but who knows what promotions service actually depends on. So understanding that full dependency graph is actually not always clear. The second thing is, even if you did know, you would need to know how to build and run all of those dependencies. And that's just a headache. It really can get very complex. And the other assumption is, actually, I can run all of this on my laptop, which, again, starts to become a real problem as complexity of the app actually grows, where you can't actually just run everything locally. So, developers have been facing this for a while. One approach is just to create mocks. And mocks do help to simplify your development environment. If I'm not really, really dependent on promotions or a review system being in place, I can just mock that out and have hotels call that mock. There's a few things, though, that you should bear in mind. One is it really does up the bar of discipline that you would need to have on defining your contracts, having good unit testing in place, which are all good things. But we also know that a lot of integration issues start really happening when you really start seeing an end-to-end flow throughout all of your system. The other thing that we've learned with mocks is, maybe this is something you can relate to, is sometimes the mocks or the simulators that you build actually end up being their own software project. Right? They actually start becoming even more complex than the app itself that it's supposed to be helping you develop. And then, of course, the more that you're simulating and mocking things and so forth, the further you are away from, there's a widening gap between dev and production again. So you're going to see nuances start creeping in, things that you didn't see while you were developing when those mocks aren't there when you're actually working against the real system. So there are pitfalls in that approach. So one of the patterns or models that we're experimenting with, and again, this is where I would really encourage folks to participate in helping us really hash this out, is see, is there another approach that we could do here? So everything that I was showing before and working with dev spaces, you could think about it as like, that's my cluster, and I'm working in that. But what if you broaden that out a little bit more and say, well, actually, maybe that could be my team's cluster. And I have the same kind of app running in my team's cluster. And the first developer, let's say Lisa, comes along, and she's actually developing one of the components here. What she can do is she can create her own space inside that AKS cluster. And she could run whatever she needs to run to be able to do her development, whatever that she's modifying there. So maybe it's just front end. And that's all that she needs to know how to build. That's all that she knows how to sync code, build, and run is just front end. She's the front end developer. She gets a public endpoint that she can test her version of front end directly. But when front end then now starts making back end calls, she doesn't need to know how to set that up, that full app stack up. It can actually just call into that baseline that the team is running inside their AKS cluster. If Lisa finds that maybe she needs to make a change to hotel as well she can run her own version of hotel in her own space as well, or not. Okay, so she's choosing what to run, and what is it that she owns and she knows how to run in her own space, running in an isolated manner, so she's not affecting anyone else in the team, but she's also being able to run her code in the context of that broader app. Let's take the other developer working maybe in the back-end service. So I really should change the name here. My name is John, and speaking myself as a third person doesn't quite fit right. But so developer working in a back-end service, let's say on promotions, same thing, can run his own version of promotions service in the back-end in his own space, and he can test that directly. In fact, you probably want to do that. Promotions has its own REST API perhaps, and you can run all of your unit tests and so forth directly against that. But what you can also do is start understanding how your code changes are going to behave in the context of the broader app. You too could also have your own public endpoint and make requests to the front end, which then makes a call to hotel, which still is running in your team's baseline. But at that point, when hotel actually makes a call to promotions, it's actually going to resolve to John's own promotions version. And so you're immediately getting that end-to-end flow, and you're getting a better sense while you're writing your code, and then being able to have more confidence when you actually check in. In fact, if while they're working in parallel, Lisa goes in and actually commits her code, and say CI/CD actually deploys and makes a change over into the baseline, that now the baseline front end has actually been modified, the developer working on the promotions service will actually get those changes immediately. They didn't have to sync to those, didn't have to know how to build the front end, but they're going to see as the baseline changes, they're getting those updated dependencies immediately as well. So I've kind of gone through a lot. We walked through a lot of animations on PowerPoint and so forth. Those are the main kind of concepts around spaces and being able to work in isolation. But I'm going to invite Lisa back on stage. This way, you're going to get maybe a picture of what the experience is, what the developer experience is in being able to work this way.
All right, I'm just going to switch VMs here. All right, so I am the newest member of the Smart Hotel 360 development team. And John's told me that there's some problem happening with the site right now. He said that there's supposed to be a site or a discount applied to all Seattle area hotels, special for build, but I believe it's not showing up or something like that. So I'm going to take a look here. You can see, hopefully from the URL up here, that I'm running this site. This is running in my AKS cluster here, and this is really my team's baseline AKS cluster. So I'm going to go back to the Smart Hotel 360 homepage here. I'm going to enter Seattle. It's a special this weekend for anybody who wants to hang out in Seattle after build. Great, I've got my hotels back. And here I can see, sure enough, normally, if there's a discount applied, I would see a strike through and I'd see the updated or the discounted price. But it looks like that's not working quite right. So I'm definitely able to reproduce the bug here. So let's start to take a look. Over here, go away, there we go. I've got the Kubernetes dashboard running for this team AKS cluster that's running behind the scenes. So we can take a look at what's going on. Whoa. As a new developer on the team, this is pretty overwhelming. There are a lot of services here, and I have no idea what sorts of dependencies these services have, how they interact with each other. Does bookings call profiles? I have no idea. I just want to fix my bug. Now, I think John told me that all of that hotel detail information on that page is from a service called Hotels. So let me focus in on that service. Here in Visual Studio, I've got just the code for the hotel service in here. I don't have anything else open up. And I've managed to look through this code and get down to the point where I found the code here where it looks like we get the discount information. And you can see that there's a call out to a service called Promotions. And that should return me the discount, and that should get the discount that should be applied. So this is probably, the problem is probably somewhere in here. But let's see what I can do to figure this out. Again, I'm not familiar with the code. The easiest thing for me to do is just to go and step through this code and see if I can figure out what's going on. So I'm going to launch this. You saw that Azure Dev Spaces button that I was mentioning earlier. And this is going to pull up the site. And now note the URL here. It's a little bit different from what I was looking at before. Before it was just sh360 and then the GUID and all that information. But now there's some additional stuff at the start of the URL. So I'm running this code now in the Lisa space, in my own space in this AKS cluster that's shared by the team. So the URL that I'm hitting is prefixed with lisa.s. And what that tells Azure Dev Spaces is that when requests come in on this endpoint, to route any requests to that hotel service into my version of the hotel service that's running. So let's go ahead and I'm going to go through the same steps here to reproduce the problem. I'm going to find a room, and I'm going to click on hotel details. And over here, whoop, in Visual Studio, it's broken into the debugger. And now I can step through, and this is running live in my team's cluster. I didn't have to set up the promotion service, or it looked like there was some sort of database dependency there. None of that is running on my local machine. This is really, really lightweight. All I have is Visual Studio, that Azure Dev Spaces extension, and then the code for the specific service that I'm troubleshooting. All right, so I called out to promotions here, and it looks like I got back a success error code. I'm going to keep stepping through here. Everything's looking great. I'm not quite sure what the problem is. All right, and let's see. So that value of discount should be applied. And so the discount is 0. That explains why I'm not seeing a discount applied, because there is no discount coming back. So I believe John owns the promotion service.
Whoa.
Looks like the bug is in his code.
It was working last night. It's like,
Sure it was, John. Sure it was.
all right. OK, so maybe we want to take a look at the promotion service. Maybe at this point, though, it would be good to call out actually what is running in the cluster. Let's take a closer look.
All right. Want to go back to the dashboard here?
Yeah. So you can see all of these services. This is the team's baseline. Is running in a namespace, which is called mainline. It's just what we picked. So actually, can you look at the namespaces on the left-hand side there? And you can see that there's a bunch of namespaces there. There's mine, and then there's also yours, called Lisa. And if you select that,
hopefully it'll refresh. I may need to refresh the Kubernetes dashboard here. Try that real quick. Here it comes. All right, so you wanted me to go into the Lisa namespace over
yeah.
here. All right.
and you can see here that the only thing actually running in Lisa's namespace is the hotel service, which she F5, and actually has a debugger attached to it. But there's nothing else, front-end promotion service, review system, all those things that we saw earlier that's running in the baseline. None of them have to be replicated. That full app stack doesn't need to be running in your namespace. Calls are being routed appropriately when you're using the lisa.s prefix on the URL. So maybe what we can do is I can run maybe promotions in your namespace, and maybe then we can see them interacting together.
Yeah, sounds good.
All right, so let me just flip over to my screen. I'm in VS Code here, Node.js app. And this is the promotions code here. And I think what you saw earlier on with Lisa and being able to connect to an AKS cluster from VS, choose a space to run in, you can just do from the CLI here. So that's just, I'll do a space list. And you can see I've, different team members have their own spaces here. I currently have John, my own space selected. So if I want to work in Lisa's space temporarily, I just say space select, Lisa. All right, so now that I'm connected to Lisa's namespace, I'm just going to hit F5. Synchronizing code into that space. using the Helm chart to deploy, building the container image, and to the question earlier on about private, non-public services, this is an example of that. There's no way to get to it other than through inside the cluster. Okay, so and you can see that I've got that localhost SSH tunnel already open. So I think one of the first things that we'll do to debug this is I'm just going to test promotions just directly. Just make sure that that is working fine. So let me just grab this URL here. Let me just curl against it. So the way that I could test the promotion service directly is /API, and the ID of that hotel
was 2, I think.
All right. So I've hit my breakpoint here, just stepping through my code. Everything seems to be fine. It grabbed the discount and is returning 200, which is seems like the promotion service is working fine. Let's just see how these two services actually interact. So rather than testing it directly, let's test it through the web front end, calling hotels, then calling into my service here. So I've got the same URL up over here, lisa.s.sh360. Let's just refresh that. Actually, I think I've hit your breakpoint.
Yeah, you sure have. So in Visual Studio, it's broken into my code here. Should I just go ahead and continue there?
Just hit at 5 there, which calls a promotion service, and now it hit my breakpoint. Okay, let's just go through here. That's not good. Hotel ID is, the ID of the hotel actually isn't coming in right. That's all right, I've got some validation here. Validation isn't picking in right. This is going to be terrible, actually. Discount is undefined. Okay, so there's a problem in your code in the way that IDs are coming into my service. But I'm not giving the best feedback. I'm giving, hey, this is success.
No, that's not good feedback, definitely.
All right, so let me just modify things. Okay, so I'm going to go in there. I think I know what to do. Let's just add another check over here. Make that validation a little bit stronger. I'm going to hit save. Just start up the node process again. Let's just kick this off again.
All right,
hit your breakpoint?
Yep, I'm going to call promotions now.
Okay, hit my breakpoint. ID is still wonky, all right, but as I step through my code, all right, now I should actually be sending you a better actual 400 saying something's not right. So at least I've made my code a little bit better. You still need to fix your code.
I don't get to go on vacation to Hawaii quite yet. Darn. All right, so let's go back to my machine. There we go. So where John left off, he just was sending the response back from promotions, and so I'm now broken into my code here right after getting the response. And all right, so let's see. Now I can see that the is_success status code has now switched to false. So that's reflecting the changes that John just made in his code. Now I'm getting a false response back.
Actually, Lisa, one of the things I want to call out is down below here. Can you see the output window? There's like a bunch of what looks like trace requests. And one of the things that we're doing as well here is not only giving you the ability to debug, but a lot of the times in microservices, there's a lot of things are just moving around, right? And so what this is actually providing is all the traces are being streamed in real time to the output window here in VS, showing all the requests that came in. That came in through the public URL, came in through the web front end, came in through hotels. I think we see later on that actually hit the promotions API, and so you're getting you're able to debug your process, and you're also getting more of the ambient information being streamed to you while you're developing. And we found that is very helpful as well.
Yeah, in fact, I guess if I had taken a little bit of a closer look before, I could have seen that my this API call that's being made out to promotions, I can see some funkiness in that query string there. So I might have even been able to fix this without your having to go in. But I didn't quite do that. And anyway, I think it's better to get the good debug information back from you. So I think I know what's going on here. So I'm seeing this ID being passed as a string literal here, and I think I just forgot a $sign at the start of this string, which tells it to replace that ID in brackets with the actual value of my ID parameter. So that might explain what's going on there. So let me make that change, and I'm going to start this up in dev spaces again, and let's see if things are looking better now. All right, I think it's just launching my browser here. There we go. I'm just going to double check again that I'm running in my space, because if I were to go to the team space right now, I wouldn't see any of these changes that we've been working on, if I'm understanding right. Yeah. Okay, cool. So here's my homepage again, and I'm going to enter Seattle. Cool. We're going to do this build weekend. Find a room, go back, and click on our hotel. And now I still have my breakpoint set, so here I come into Visual Studio, and I'll step through here.
Which just made a call to my modified promotions.
Exactly. Oh, and it looks like things are looking better. I've got a success status code of true now, so that's a positive step. And let's keep stepping through and see if I get my discount applied here correctly. And the value of discount is now 0.1. So it looks like we fixed, well, let's just continue and double check that we're seeing that actually in the web browser. And sure enough, there is my discount being applied.
All right.
So,
cool.
Yeah, looks like we fixed 2 bugs there. So
$2 for the price of 1.
Exactly, cool.
Yeah, awesome. Okay, so you saw a lot of things there. Let me just break it down a little bit more. So remember, the scenario here was that Lisa was a new team member. There's a lot of moving parts in the app. Her first day of fixing a bug on the team, working on one particular service. We saw the lightweight experience. For her and working in Visual Studio, all that Lisa needed to do is install Visual Studio, install an extension, and then she's up. She's got a connection to the team's AKS cluster. And she was able to work in her own space, in her own isolation there. Her own hotel's service. But then she also had her own URL, where she was able to push requests through the system. But whenever it made a call to her, to the hotel's service, it was directed to her version of hotels. And then being able to test things end to end and being able to iterate on that just gave us a lot more confidence that the fix that we worked on, which ended up being kind of in the space between 2 services, we have more confidence now that when we actually go and check this in and the team's baseline is updated, that we're in a better position. Okay? Some of maybe the questions that are coming to mind is, the experience seems good. How does this all work? So what I'll do in the next couple of slides is just go a little bit deeper, start peering under the hood of how all this is actually working. So that way, almost just demystify how this is working to enable this experience. So one of the first things, or the requirements, is that in each of those services, whenever they're making downstream calls, that you're flowing the HTTP headers, whatever you got from in your request, as you're making downstream calls, that you flow the same headers. And that information is required to be able to make those routing decisions inside the team's developer cluster. You don't need to necessarily write that code yourself. One of the things that the prep command does is actually give you a helper so that you can just use that function. So here, what I show here is some .NET code in using HTTP client. You could just change that to header propagating HTTP client, which is that helper method that we give. And all it does is it's a subclass that just forwards along headers. So that's really all that the requirement in your code that you would need to do to be able to take advantage of some of that routing. Let's peek under the hood of some of the moving parts here. What I have on the screen is the development client on the left-hand side, whether that's your CLI, Visual Studio, VS Code. On the right-hand side would be an AKS instance. And alongside that, the Azure DevSpaces service that is connected to it. And inside here, I've got hotels and promotions that are running in a namespace called mainline. And if I've enabled DevSpaces in this Kubernetes namespace, then I also, whenever I'm placing containers in it, I also get some instrumentation around it. That's what makes all the tracing work, or the debugger ports open up. You just get that automatically by placing containers inside that namespace. AKS also has Nginx ingress already baked in. So what happens here? When I do up on the CLI or hit F5 debug in Visual Studio, code goes over to DevSpaces, which actually starts orchestrating some things against the AKS cluster. It does a Helm install using the chart that you have in your code to deploy the container in your space. Source code is volume mounted into into that running container. And then we're using a new feature in Kubernetes called initializers, which enables us to be able to run another init container inside that namespace to be able to get things up and running, to do the build, to be a little bit smart about, should I do a full build of the container, or should I just update Node.js or .NET build. And so now I've got my own container running in my own space. And so now suppose you go to the browser and you make a call to hotels. Now, Lisa was showing that she was prefixing the URL with her space name, lisa.s, which when that goes into the AKS ingress, there's a rule that we place there that just looks for the presence of any prefixes there for a space, and then turns that into just adding some HTTP headers for you, so that now they actually start flowing through the requests. So a proxy that's sitting alongside hotels here sees that. The call to hotels is resolved in the main line. But then when hotels actually makes a call to promotions, it first uses Kubernetes DNS lookup and sees that there is a promotions in the mainline namespace. But the proxy also notices that there actually is a promotions version running in Lisa's namespace. And so now it's actually just going to route to Lisa's own version in her space. And that's basically how this is all kind of working. Not so much to actually understand that maybe all the details here, but maybe my uber point here really is that a lot of this is kind of just packaging up some primitives that are already in place in Kubernetes. Kubernetes namespaces, Nginx ingress, using initializers, using sidecars to be able to do some instrumentation and so forth. Basically, we're packaging all of this up to be able to provide a good experience. But it's built on these primitives that are really there in the platform. I'm not sure I caught the question.
Is the SSH port configurable between the development client and your DevSpaces?
The question is the SSH port configurable between the dev client and the Azure DevSpaces? Can you describe perhaps the scenario that you have in mind?
Is that there's corporate firewalls in what our developers develop in, and certain ports are walled off?
Yes.
That would be an issue.
Right. So the question is, or the scenario is that you might have some firewall or some ports that are firewalled, and that from the developer workstation doesn't have connections to. This kind of comes under the umbrella that we've been looking at around custom VNets and enabling that. We actually have some folks running in the private preview that actually have that very setup, where their developers are connected through VPNs. And so we're working through the network ramifications of that so that you are able to be able to run in that kind of secure environment. So it is a scenario. We're working towards it. You do have control over quite a few places where each of these things actually run. Another question.
After you make all these changes, is the process of like having your own branch and then submitting a pull request to get it back into master, would that be all the same? Or would there be a different process for like merging it?
That's a great question, which is, if I could maybe paraphrase, what's the process of all this around maybe Git branches and you're making pull requests and merging this back into main, and is that general the question there? It's a really interesting question. It's actually something that quite a few folks have raised in terms of being patterns that could be applied here. There is no direct relationship between what branch I currently have checked out and what space it actually runs in. But it's something that we are thinking of whether there's actually more integration there. So the answer is you actually have full flexibility about which branch you want to run, where you want to run it, how you want to merge. But I think that there's some opportunity there to be able to make that simpler. And in fact, if we have a little bit more time, I'll cover a little bit maybe of how does this all fit in with CI/CD and branching and all that. Question?
Is .NET Framework supported?
The question is .NET Framework supported? Absolutely. And you saw Lisa first in Visual Studio, the hotels service, for example, was .NET.
No, .NET Core.
Oh, right. .NET Core versus .NET Framework. Okay. So at this point in time, .NET Core is what is supported. With AKS, we're working through the Windows scenarios there and be able to eventually actually provide full .NET Framework support. So it's something on our radar, currently not there yet. All right. So again, I'll paraphrase there. The question is, not all of your services would be communicating over a direct HTTP requests. Is that the question?
No. Microsoft discourages creating a new HTTP client for every request. Everyone should use a singleton because otherwise there is socket exhaustion.
Oh, I see. In terms of the patterns in which the way that HTTP client is actually used. And my sample there showed always creating, that's a bad in my sample. In the same way that you can use HTTP client and just having that one connection, using it as a singleton, you can use it also, you can use exactly the same patterns there as well.
The main problem is that you are actually passing this request while creating the header forwarding HTTP client, so you cannot use it any other way unless there is some kind of caching and just injecting the request headers into an existing HTTP client.
So maybe we can take this offline, but what I was showing there is a service receives a request, so now it's actually doing some work, right? And certain headers came on that incoming request. Now it's actually making calls out to other services. And the requirement here is if you want to be able to get this kind of routing working, whatever requests, whatever headers came in on the incoming request, that you actually just forward, add those same headers on any outgoing requests that you make. I'm sure if that answers your question. If not, we can take that up offline after. I have a few more minutes. I'll get through the remainder of my slides, and I'll then make sure that we have some time to get to any other questions. Okay? Because I wanted to just be able to maybe zoom out a little bit. One, we started, remember, at the individual developer level, being able to get your individual container running in your own AKS cluster. Then we jumped up and being able to say, well, how does that work in a team environment? And we showed that. And I've been iterating that a lot of this really is about iterating your code pre-commit. Okay, so how does this all fit in, perhaps, with a broader development lifecycle? So what I'm showing over here is an AKS cluster on the right-hand side here. Let's say that I have two namespaces, one called production, and it's running all my production containers in there. And maybe I have an integration namespace, which is running my integration containers there. Now, most probably and often, you would actually be running production in a totally physically different cluster. And that's okay, you could do that. I'm just showing that there is separation between one namespace in which I am using dev spaces, the one on the left-hand side, the blue one there, which has all of that instrumentation going on and debugging and so forth. But that is contained to that just one namespace that I have enabled dev spaces on. Anything else that I don't want any of that instrumentation, touching, opening up, debug reports and so forth, remains untouched, unmodified, not instrumented. So that's number one. Then as a developer, you can go out and you say, well, actually, I want my own namespace. So Luana on the left-hand side is running whatever containers that she needs. And then she's also able to interact with the team's baseline namespace. And you would have each of the developers being able to just run in their own namespaces and have that instrumentation. And again, all of this is pre-commit. At some point, you're like, OK, now I want to actually update my team's baseline. Well, the developer will go in there, do a git commit, git push, going out to source code control, and whatever CI/CD pipeline you've set up. I hope that you will take a look at the new DevOps project, which helps to actually set up a lot of this CI/CD, container registry, AKS cluster, all of that kind of setting you up well to have all of that running together. But you could use whatever CI/CD pipeline that you want here, which would be building your container after you've on your committed code, pushing it to a registry, then doing a Helm upgrade install into the integration namespace. And whatever you put in there ends up being, because it's dev spaces enabled, ends up having that rich instrumentation. If those look good and you actually want to release to production, well, that's just a CD. It's another Helm install to another production cluster or a production namespace. In which case, none of that instrumentation is in effect for that latter namespace. So wrapping it up, Azure Dev Spaces, hopefully you've seen how you could really rapidly iterate and debug Kubernetes directly in AKS, and also how we're just making a lot of the team development experiences, particularly that get exacerbated during microservices development, and making that a lot more efficient and lightweight in terms of you have to set up and then working and then doing end-to-end testing. Quickly on our roadmap, where we currently are, we're in private preview. We're actually expanding membership to the private preview. What's on our radar? Things that we're working towards is having custom VNet support. The experiences that I showed today, there's a certain baseline experience that you have in the command line that applies to all languages. But what I showed around richer debugging, iterative development inside VS Code and in VS, today applies to Node.js and .NET Core. We're expanding that to other languages. We chose those two languages, .NET and Node.js, because they're very, very different in the way that containers are built and the way that those apps actually run. So we think we have a pretty good handle to start adding more language support and richer language support going forward. So Java is our next one. more integration with DevOps projects, more portal experiences, expanding Azure regions. If you want to sign up for the preview, again, we are expanding this this week. So the ak.ms dev spaces, just sign up there. And I really look forward to being able to touch base with you, learn about your stories, and have you participate and help shape this early developer service that's there. Thank you very much.